Okay. So in the question, a point source of heat of power P. He gave that the point source of heat of power P is placed at the center of thin spherical shell of mean radius R. The material of shell has thermal conductivity K. Calculate the thickness of the shell if the temperature difference between outer and inner surfaces of the shell in steady state is T. So he gave a thin spherical shell and there is a point source here. Point source of power P. So here the heat is generated in this way with the power P. So he gave the mean radius of the shell is R. So mean radius means this average radius. As it has inner and outer surfaces, the mean radius is R. This is outer surface and this is inner surface. So let me explain the question first. So a point source of heat of power P is placed at the center. So power source of power P is placed at the center of this thin circular shell, and at the center mean radius is given as R, and the material of the shell has thermal conductivity K. So this shell material has thermal conductivity K. Calculate the thickness of the shell if the temperature difference between outer and inner surface of the shell in steady state is T. So the temperature difference between these two is T, and we have to find the thickness of the shell. So we have to find this thickness. So normally the main concept involved here is there is no loss of heat. So rate of heat generated to any body is equals to the rate of heat energy transferred. So here the source is this point source. So the rate of heat of energy will be transformed by the point P source. So the source is P. So delta Q by delta T generated is equals to power P. So we know that power can be defined as rate of loss of heat or rate of change of energy. So we can take this as equation 1, and rate of heat energy transferred. So we know that delta Q by delta T, as we discussed earlier, K delta T by X. Here delta Q by delta T is rate of loss of energy or rate of transfer of energy. K is thermal conductivity. A is area of the surface or body, and delta T is change in temperature. And X is thickness. So here we can take this as equation 2, and equation 1 is equals to 2. So P is equals to K delta T by X. So we know the value of P, and they gave thermal conductivity K, and we need to find area. So here area is area of this thin spherical shell. So we know the area of spherical body is 4 pi r square. So we are given with the mean radius r, so we can take area as 4 pi r square, and they give the temperature difference between outer and inner surface of the shell in steady state is T. So we can take the change in temperature as T and X. So we have to find this value X. What they asked to find? Calculate the thickness of the shell. So the thickness of the shell is X. So transfer it here. X will be K into 4 pi r square into T by P. So this is the answer. So the option is K 4 pi r square KT by P.